So this part is power to a power, which means I multiply. 3 times 5 is 15, 2 times 8 is 16, so that's straight across. Then k to the 5/16 times k to the 15/16. They have the same base, and I'm multiplying, so I just add. So this ends up being k to the 20/16, which is the same thing as 5/4. The root is on bottom. The power goes down from the numerator, so I'm looking at b. What is the y-intercept of this graph? That's when x is equal to 0, so -8 times 6 to the power of 0 minus 4. 6 to the power of 0 is 1, times -8 is -8, minus 4 is -12. The property we're going to use here is that you can split square roots like this. And what happens is on the top you can't simplify, but on the bottom the square and the square root go away. That's why the answer is C. So to make a substitution here, I'm looking somewhere to find 3x minus y. There's a trick with the same base where you can subtract exponents when they're in a fraction form. So as long as I change 8 to the x to 2 to the power of 3 to the x, or in other words 2 to the 3x, now when I divide by 2y, this is the same thing as 2 to the power of 3x minus y. Since I can plug in for that at 12, this is the same thing as 2 to the 12th. We can rewrite this part of the equation as the nth root of 2 squared, because the denominator is the root and the numerator is the power. This can also be written as the nth root of 4, because 2 squared is 4. If I multiply that by the nth root of 3, they have the same root, so this becomes the nth root of 12. So the first thing we do is take the cube root of this whole expression squared. So I'll then expand this, and this gives me 2q, this gives me r, this gives me root 2qr. When I combine like terms, I get 2q plus, and this is right about where I think this should be a 2r as well, because if it was, this would be a 2, this would be a 4, and now I can pull out the square root of 4 is a 2, and I have 2q plus 4 root qr plus 2r. And all of this is still underneath that cube root, which gives me d. So we're going to take 4 times 3 squared, which is 9, times x squared, all over 2 squared, which is 4, times x squared. The 4's go away, the x squareds go away, the answer is 9. So another way of writing this is x to the 3/2 to the power of a, and since it's power to a power, I multiply, so this becomes x to the 3a over 2. And if 3a over 2 is equal to 6, then 3a is equal to 12, and a is equal to 4. So another way of writing the root of 4x is to write it as the root of 4 times the root of x, so this is 2 root x. Another way of writing root x is x to the 1/2. The mistake that people make is they forget order of operations in the sense that you have to do the exponent before you do the multiplication. There's no parentheses, so that's why. So we can start with this part here. 3 to the -2 is the same thing as 1 over 3 squared, or 1 over 9. If I take this to the power of x plus 1, I can write that as 1/9 to the power of x plus 1/9, multiplied by 1/9. Another way of writing 1 over 9 to the x is 1 over 3 to the 2x, because that 1/3 squared gives us 1/9. Put it all together, you get b. What is the y-coordinate of the y-intercept? So that means that x is equal to 0. So 3 to the power of 0 is 1, plus 9 is 10. the square root of a is equal to the cube root of b. So I can also write it like this, and if I cube both sides, I get that b is equal to a to the power of 3 halves. So 3 halves is going to be 2x minus 1. So 5 halves is going to be equal to 2x, and if I divide both sides by 2, I get 5 over 4. Or 1.25.